right. Hello, everyone. This is Max with ACS, and we have Greg Seal from Cognex. We are going to do a ViDi Color demonstration today. Thank you guys for joining. A couple of notes. We're going to have everybody muted for the presentation, but there is a chat window. If you guys would drop any questions you have in there, we will take the time to answer them as we go along. And of course, Q&A at the end a little bit for any other questions that you have towards the end. I'm going to let Greg take over the presentation. And yeah, if there's anything in the chat box, just let us know and we will get them answered.
All right, thanks, Max, and welcome everyone. Really excited to discuss a little bit some of the power that color brings to deep learning machine vision applications. I've got a little presentation that I'm going to go over with everyone, and then we've got a little fun Halloween-themed live demo that we're going to show, and then we'll also show some past applications and kind of discuss, again, what color brings to deep learning, and I think it's something that adds a lot of value to these systems. For those of you that don't know me, my name is Greg Seal, and I am the account sales engineer in Georgia for Cognex, so pretty much all things Cognex in Georgia. So if there's anything in here that sparks your interest in the applications, or you want to dive a little deeper in any of the discussions, we can send out my contact info, and I'd be happy to continue any discussions that aren't answered in this session. So I'm going to go ahead and kill my video because I'll be looking over the side, and instead I will be sharing a screen. So let me turn that on. So Max, can you guys see my screen here?
We can see your screen.
All right. So again, I just want to do a quick little presentation, just discuss on some of the points of what color brings to the table here. Brief talk on the D900, but this is more focused on kind of more of an informational webinar as well. So hopefully you'll learn some things today. All right. So why is deep learning in machine vision important to you? Well, what it does is it brings the human factor into play while also keeping an automated dialed-in machine vision system. So it adds a lot of flexibility in terms of analysis and imaging, and it keeps that same consistency that you have in a machine, right? So it's able to pick up a little bit more than just looking at contrast or looking at changes of shades in the image. It's able to think a little bit more like a human might think, while also, dialed in, thinking the same exact way every single time. A camera doesn't have to go to the restroom. Camera doesn't, get distracted. Doesn't go on vacation. All these things that we're all human. We all do these things. But you dial in that camera, it's going to work the same way every time. And the deep learning adds a little bit extra power to it. And we're going to show some examples of that as we get going through this today. So if you've seen our previous webinar, or if you've talked about deep learning with me before, you may have heard this example. And I apologize if it's a repeat, but I do think it really hits home on what really deep learning is compared to what we call traditional rules-based vision algorithms. And so we use this analogy a lot. And again, I think it just really hits the point. And what it is if you're trying to teach a child what a house is, in a rules-based approach, what you might do is you might say, okay, a house has 4 walls. A house has a front door, it has a window, it has a roof, it has a floor, all these things. Well, guess what? I bet a lot of you are sitting in buildings right now that have all these things, but aren't houses. Okay, an office, the ACS office, the Chick-fil-A, the Cognex office. All these things are under these same rules, but are different. And that's kind of a good way of showing, hey, there's some things that some exceptions that can come into play when you do a rules-based approach. So what's a deep learning-based approach? How do we think of that? Well, it's by example. So the idea is you take your child, put him in the back of your car, and you drive around town, and you point out, that's a house. That's a house. That's our office building. That's a manufacturing facility. And that way the child is able to learn and pick these things up. It's by example, and then you kind of see what the differences and similarities between a house versus these other type of buildings that maybe have the same structure, the same rules that a house would follow. So that's kind of the idea there. Again, I think it just does a really good job of showing the differences between the two. And again, this is one that if you were in the last webinar, maybe a repeat, but I think it's really important to kind of debunk some of these buzzwords that you may see in here. I would say artificial intelligence, the biggest one. Everyone is saying AI. It's huge. It's this whole new way of thinking, a way of doing things. But not a lot of people are really doing true AI. There's these subsets within AI, machine learning, deep learning, all that. So what is AI? Now let's say we had a camera, and I put it over my machine, and I put it on my process, and I run 50 good images and 50 bad, and I tell it those were good, those were bad, create my vision program, and hit the ground running. Right? No one's doing that right now. I mean, that may be way down the road. We'll see. But we don't have the full AI yet. But what we do is subsets. Now, machine learning would be a subset of AI. And there's definitely people in the manufacturing space that are doing some machine learning. I don't see it in vision yet, and I'll kind of explain why, and maybe some of the dangers or some of the risks that would come into a machine learning system. But the idea of the machine learning system is you still have the user input where they teach the system what is good and what is bad and all that. But with machine learning, it continues to learn. So as it's taking images, as it's doing its analysis, it's learning as it's going. And it sounds great, it sounds really powerful, but think about what happens. Let's say it found one product that was bad and it thought it was good and it added that into its learning set. Well, then you're going to start to get a snowball effect, and you might start adding more bad into good, and by the end of the day, you might have a system that's kicking out all your good products and accepting all your bad. So it's a risky balancing act in machine learning. I do know there are some companies doing some stuff where they're tracking, acceleration and torque on rollers and conveyors, and they're able to learn when the preventative maintenance, things need to be replaced. And to me, that seems like a really good application for it. I don't think we're quite ready there in machine learning, but I'm sure it's going to come before we know it. So the bottom one here, it's the bottom subset. Might look small in this image, but is really powerful, and that's deep learning. And this is a whole new, revolutionary technology that really is changing what we can do with these camera systems. And that's basically where we're learning by example. We're doing this this example-based approach. We're feeding images and images, and we're teaching the system. And by that, it's able to become a lot more powerful than a traditional rules-based system may be. And we've seen that in the real world. I mean, we've been able to accomplish like so many more applications that we just couldn't approach until we have this technology. So just real quick to show how these type of systems work, at least the D900 that we're looking at today. So you don't need a PC or a controller or anything like that to run the system. Similar to In-Sight Explorer, for those who are familiar with Cognex and our In-Sight product line, is you do need a PC to set it up and set in the parameters, tell it what you want it to do, teach it, and that's what you would do on your PC. You would develop that program, and then you would deploy it on your camera, and then everything would run on the camera, and you wouldn't need any PC or anything connected to it. It can talk straight to your PLC or whatever you want it to talk to over Ethernet or discrete I/O. So again, this is an embedded system, and it does all the thinking on the device, only the PC for teaching and stuff. So what do we have today? We have the new D900 Color, and what that brings to us is the ability to take color images and do a color analysis in deep learning, create a color neural network for this camera. This is we've had the grayscale out for a few months now, been very, very successful, been really nice seeing all the new applications we can approach. But now that we have color, we can open even more doors. And so this is where I'm going to start talking about what color brings to deep learning. Why is color better, and why do we like color more now than maybe we have in the past? So an equation, very simple equation I came up with that I want to share with y'all is more data equals more power. We got more information, we got more to learn on, a lot of great things. One more point I do want to make that I'm really excited about in this new camera is HDR+, and I will show an example of the HDR+ technology with our color cameras. We've had it in grayscale for a couple of years now. It's been really nice. It's improving depth of field, improving contrast, adding light when we don't have light, and now we can do all of these things with color now. So very exciting stuff, the new technology coming out here with this new camera. So what makes color so important? Why do I keep preaching saying, hey, we got to have color? It makes our neural network so much stronger, so much better. Well, to do that, let's take a step back before we explain that. I want to explain, where we got with grayscale imaging and why grayscale is kind of the industry standard in machine vision, or typically the preferred method. And if you think about a grayscale image, it's broken down into pixels, right? You got your image and you got X amount of pixels, and that's your image. And each one of these pixels has a contrast value. And that contrast value is just between 0 and 255. And it says how white or how black that pixel is. And that's it. And then you have all these pixels with that certain value applied to it, and then that's how you do your analysis. So with a rules-based approach, having just one channel of data is much simpler to inspect. It's easier to make tools for it. It's more robust. You don't have as much changing factors in your image. And that's kind of why with rules-based, we always said, hey, let's do grayscale unless we need color. Well, we're kind of changing the game here. So with this color image now, each pixel has 3 channels now. So it has a red value, a green value, and a blue value, all 0 to 255. So again, with rules-based, it may add more things that could change in your program and make it maybe not quite as robust as a grayscale imager. Now with deep learning, it's kind of the opposite, because it's more information for the neural network to actually learn off of. So with that extra information, we can make more robust, more reliable, and more powerful applications. So remember that, for neural networks, more data equals more power. But why do we not always use color, right? If it's this great new feature we have that can give us so much more information, it does have a drawback. And with more data equals more power equals more processing time, right? There's more information, there's more processing that goes with this to be able to get where we need to with these things. So the idea is, if you can use color for deep learning, it may be a good idea, but you want to make sure you've got enough time with your hardware that you're using. So, like vision, every application is different. Every application has its own way of being solved. Same thing here, but typically, if you can use color, it can be more preferred with deep learning. So let's look at some examples here. Let's dive into, kind of put some proof in the pudding. So first over here on the left, we have an assembly verification. I want you to take a look at this yellow part here, right? This really stands out to me in this image. It really pops on a white background. It's a light yellow, but it really is noticeable in here, really easy to identify. Well, in a grayscale image, yellow would be kind of more on the white scale. So this would really blend in with our background here, harder to see, and really would not give that nice pop and that contrast in the image. And again, with deep learning, the idea is we're mimicking the way a human brain would look. So if that pops out to you, that's going to pop out really nice to the deep learning camera as well. So that's kind of the idea. And then again, same thing with the foreign material here. We've got all this, I think it's some beef or some steak, and you've got some white glove in there. Again, that really pops out, makes it really obvious, where it'll be kind of a more of a neutral color almost in a grayscale image. So. And I've got some more foreign material stuff to show as we get down further into this presentation. This one over here on the left really calls out to me. I'm a big fan of this application. I think this one does a great job of showing exactly the power you get out of using color in a neural network for machine vision. And look at this. I mean, you've got a white plastic, kind of like, looks to me like a yogurt cup or something, and it's got some white yogurt coming off of it. Looks very similar, but you can look in the color image and you can see that has a different shade of white. So there's definitely much more noticeable, where in grayscale, you'd be able to see the difference in the image, but it would be a very similar contrast or very similar shade to the rest of it. So I think that's a perfect example of where color can come in and give you that extra little bit of power you need to solve your application. Then again, over here down on the bottom right, another really good one with 3 different objects that are grayish in color. And again, these are color images, so it brings out some extra data, and it lets us be able to classify the differences, where if these were grayscale images, they would all look very, very similar. So Cosmetic Inspections, very good one for color as well. Does some things where you can pull out extra data. It's a lot more noticeable with color, especially when you have differences that are cosmetic. Things that look off or look different. The color really brings that into play and lets you really see that. Got another one over here too, as you can see on the this is a filter and the color. We've got some specs here. These are the raw images on the right. You can kind of see these little dots. Again, grayscale, these would look very neutral compared to the background. Where here they really pop, and ViDi does a great job of picking them up, saying, "Hey, I see all your cosmetic defects on here. Something's different from what you taught me. That's a defect." All right, so that's kind of what we got for the quick presentation. Then I want to jump into some examples. Do you have any questions at this time, Max?
At the moment, we have not gotten any questions, but please put your questions in the chat box, and I will get them answered for you as we go along.
All right. So I've got a couple examples here. These are our ViDi reports. So this is, we can create a report based on an application. And you can see here what we've done is we've created a bunch of samples of different beer and vials, because you can see very, very similar in color, very similar in appearance, but the system is doing a really good job at picking them up. The way this application works is we taught half of the images what it was, and then we process on the other half to see how reliable we are. And as you can see here, this is a perfect score. So ViDi did a really good job at picking up these minute color changes. What I want to do is just come down. I got one example here I want to show. And I think this really does a good job of speaking to the first slide where we talked about the ability to combine the way a human brain thinks with the way a machine works. And these two examples right here, I'm going to click on this one, Big Chaser. I'm not quite sure what beer that is, but you can see it's some sort of light beer. And then we got magnets here, also very similar. So here's the idea. You can look at these, right? And you can probably see there's a slight difference. There's not a lot in there, but there's a little bit of difference. But what happens if I zoom up and came down and asked you to remember what those differences were, right? Or what happens if I did that and then came back tomorrow and asked you? I can tell you I definitely wouldn't have any idea which was which. But that's the beauty of adding the machine in there, is it's able to save that into memory. That's the only thing it's thinking about. It's not a human, doesn't have a million other things on its mind. It's focusing on that, and that's all it does. And as you can see, ViDi does a great job picking that up. 100% confidence, that's what we want right there. So again, one of these applications, try to do some grayscale, no chance. All right, so let's jump to the next one. This is a 400 material one that we did.
Before you jump into that one, we do have a question that came in, and I think it's relevant to where we are.
Sure.
Alec wants to know, what is the typical process flow to train a deep learning camera system?
That is a very good question. And it kind of is funny because you can kind of have that chicken or the egg situation, right? But the idea is typically the first step is to acquire images. So you would put a camera, whether it's on a line or you can do it in a lab setting, and you would take those images and you would look through them and you would say, all right, let's say we're just doing good or bad. We'll keep it simple for this. You've got these 50 good images and you got 50 bad images. You would separate them, with a human. Again, this is where the difference between machine learning and AI to deep learning comes into play. But the human would have to go in and separate the good and bad. So you have two, we could call them folders. And then you would take those images and you can pull them into our ViDi software, and then you would just label them and say, these are good, these are bad, and you literally just tell it what they are and you have it trained, and then it'll go through and it'll provide some feedback. And you were right, Max, it's a perfect opportunity to jump into that question, because what I'm going to do here is show you the feedback I'm going to give you. And this is a distribution chart that it's going to give you, where all your good are going to be over on this side, categorized here. And what this is how close to the norm they may be. That's the sensitivity value it'll score. And then the one over here is the how different from the norm, so how extreme they are. And so you would look at this graph, and the idea is you want a nice clean separation as we have here, and you would do some thought process and say, is this what I want? And if it's not, well, you go and take more images, and maybe make some changes, and you just kind of go back and forth. And what's great to this is, let's say you did the 50 good and the 50 bad. You want to keep those images? Well, guess what? You can just add on that. So what you would probably do is you would save that program as you've got it, put it back on the line, or go back to the lab, take some more images, see what it analyzes, but also take more images, and then you can throw those back and then feed on top of that. So now we've taken, let's say 50 more good and 50 more bad. So now we've got 100 good and 100 bad, and it's learning on that, and it continues to go. And there's some more you can do with this too. You can do some kind of reiteration where you can, see what it says, and you can, tweak some things and continue to change it. But that's really the basis to it. So I hope that answered your question, Alec. If not, let me know and I can speak further on it. So this is our training set where we taught it with our defects. So I'm going to jump just down to the bottom, and I do want to show some examples. I think there's some really good examples of what color does with these, what can do with these images. So again, we've got something kind of light here. You can see this would probably not be even, barely could even see it in a grayscale image. We've got it here, and I'm just gonna look. There we go. This is one I wanted to point out too. This is a piece of wood, and you can see very slight color change, and it doesn't have the same consistency as our bacon. So that's really, I think, what's able to kind of pick up and understand that it sees. Again, we've got some clash with some glare, things like that we're picking up on. Some color, obviously, that's going to be a little bit easier to do. And I think this is another good one. I think this is some sort of copper with a brown cover. You can just see, again, in the grayscale image, I bet this would look very similar to the bacon. And here, it's able to pick it right back up there. So again, something that without a grayscale, or excuse me, without color, don't think we could do this. So that is what I have for my examples. Now I want to jump over to my live demonstration. Before, I'm going to set the theme here. We're getting close to Halloween, right? So we're going to have a little fun with this one. Let's say, you or maybe your child, you've been out trick-or-treating all night. You're out, going door to door. You're working hard, getting all your candy, and you got your candy bag. You get home and you're ready to just dive in there, ready to get all that candy. But before you do it, you want to count what you got, right? You got to know your loot. You got to look into this and make sure it. And what if you got a brother or sister looking over your shoulder? Might want some documentation of what you got. That way, if there's any arguments that come up, you got something to lean on. So you're in luck because we here at Cognex have developed a candy counting deep learning system, and that's what I'm excited to show you all here. So this is my setup. This is our web HMI. We've done some customization to it, as you can see. I will jump. Let's see if we can jump over to my webcam just to show you all what we're working with. So this is my D900 setup. I've got my Ethernet to my computer. I've got my power and I/O going back to my power supply. I got my loot over here. We're about to count this and make sure we've got everything documented and good to go. So. Here we go. Let's see what we got here. I'm going to put a Snickers in there, and I'm just going to tell my camera to take a picture. So found the candy. So the first thing we're doing is locating. So we're using the location tool and found it, and then we're identifying it. So we found the Snickers. We add that to our table here. Let's add maybe a M&M and see what it does. All right, picks up the M&M, says I know that's M&M, counts that. Now let's really show the power of deep learning. I'm going to add another M&M, but this time it's got a different graphic. Look at that. Picks that up and it can recognize that is M&Ms. I know that. Let me add my Twix in there. See how this guy does. Counts my Twix. That's awesome. There we go. Picking that one up. Again, let's add a different type of M&M. Let's see if you can see the difference there. Oh, picks it up, adds to my peanut count. There we go. I got peanut M&Ms. I got regular M&Ms. We'll add another Twix. Let's see how this guy does. Snap another picture. There we go. Count my Twix. Beautiful. Gonna add some more Snickers into the mix. Keep it going. All right, found my Snickers. Love it. You know what? Try and mix that guy up. Let's see how that does. Change the graphic on me, picked it up, no problem. Beauty of deep learning. And let's add the rest and see how it does. All right, so there we go. Picked up all my candy, identified my candy. I've got a running count right here. I'm going to export this to a CSV file. I'm going to FTP this image to my PC. So when my brother or sister comes trying to get my candy, I have got my information here proving that I've got this count. This is my candy. No one's touching it but me. So, this is the idea, just showing what we can do with it. Again, we've got a brown background, brown text, brown covers, all these things that I think without color we really couldn't do this like we can with the color system. I just wanted to show something here, have a little fun. I will say. This camera is coming out. It's actually going to be released tomorrow. So that means if you want to get this camera before Halloween, so you can take it, set it up, count your candy. We got you. Contact ACS or myself. Had to get it out for Halloween. So I think I don't know about you guys, but I'm ready to go. But yeah, so that's what I have today. I don't know if there's any other questions or anything else. I appreciate everyone showing. It was kind of a quick demonstration, but just wanted to show some of the power of what we got when we bring color to the table in deep learning.
Alec did thank you for your answer earlier, but currently we don't have any other questions coming in. But does anybody here towards the end of the presentation want any more information on anything particular? Have questions? Give them a few seconds to answer. We did get a good comment that this is the best way to sift out the Tootsie Rolls and candy corn from our
Exactly. Yes.
Okay, let's see. What are the factors that go into the learning graph? Good versus bad curve.
Good question. So we will jump back to the curve. So typically what happens here is you're teaching it, there's two ways of teaching the system. And one is by what we call unsupervised. And that is where you feed it good images and it learns off the good images. And so what it's going to do is going to give a value, and it can change based on the application. And I believe it's based on the complexity of the mathematical equation that is needed to solve what you're trying to do. And what it does is it learns off what's normal when you do that. So let's say you got 50 good images, and it looks, it doesn't have to be exactly the same, because that's kind of where deep learning is power comes from, is being able to handle variation. But it would be basically how different the image it sees, or how close the image it sees to what it was taught. So for this example, what we're saying is anything over in the 0.48 or less is close enough to the norm that we know it's good. Anything over here means it differs enough that it's probably got something wrong with it. So it can be different per application, but basically it's a value that gives you how close or how far away you are from what was taught is good. And then you can use that to adjust your sensitivity. So in my software, I can move these around if I wanted to make it more sensitive. You can also export it to be adjusted in the spreadsheet as well on the fly.
You wanted to add in color, hues, shapes, contrast, etc. with the question mark?
So it's more of looking at the entire image than actually color and hues, or like, with a rules base, you might look at the RGB values of image. This is taking in the entire image or the entire view that you taught it. So I think it's more, to be honest with you, I don't know exactly what's going on behind under the hood. That's for people that are much smarter than me, but I do know it's a little bit different than just contrast and all that. It's actually taking in the full image. But that's a good question. And that is actually one of the reasons why deep learning is more powerful, is it's not reliant on set numerical contrast values where traditional rules-based vision tools are.
Okay. We'll wait a second to see if we have any other questions, and I'm actually going to type in info ACS-GA. Alec did say, okay, deviations of overall image standard properties.
Yes, my rule of thumb is how much different does it look than the norm. And if you can see a noticeable difference from what your normal good product is, then it should be something we can pull out with deep learning. We got to be able to see it, but if you can see it, and as a human, you can look at that picture and be like, that's not supposed to be there, that's not normally in my image, then we should be able to teach the system to do the same.
Thank you. Just typing in some information for the guys. So I have typed in the info@acs-ga.com email address. We can take any extra questions that you guys think of after the demo, or if you would like a demo or have applications that you would like to prove out, we can set you up with local guys and guys that are specific for your area. So just let us know about that if you have anything.
And I think also, I believe the ACS will also be supplying lunch gift cards for everyone that stayed the whole time. So thank you for those that did, and I'll get with the person who set this up, and we'll make sure those get distributed for those that stayed and watched. And appreciate everyone's time. And I think the email that Max shared with everyone would be a great way if you want to get in touch with me and discuss any of this further, or if you have any applications that come to mind.
Yes, thanks for reminding me about that. Yeah, since we can't meet in person with the interesting times we're in, we will be sending out a lunch gift card for you guys.
All right.
Alex says thanks, and thanks for everyone else coming in. I don't see any extra questions, Greg, but Greg is with Cognex, our partner with Vision, and we thank him for doing the demo. Anything else, Greg?
No, just thanks for everyone for joining. Hope it was fun, and hope you learned a little bit. So thanks a lot, and hope everyone has a great rest of your day, and happy Halloween.
Yep. Thanks for watching the video. We did try and slam it in a good 30-minute break for you guys. We don't want to take too long, but like I said, the info box is a great way to get in contact with us, and we can give you more information and more personalized demos on your parts if you have applications. Thank you for joining.
All right. Thanks, Max. Bye.